This is the lesson video for 8-5 Day 1. In Chapter 8 in the beginning, we learned how to multiply and have multiple distributors in order to take polynomials and multiply them by each other. Now in this section, we're going to go in the opposite direction. We're going to take something that has already been simplified and see if we can get back in its multiplied form. And math has reasons for wanting expressions in their multiplied form. So our two objectives in this section, and we're going to spend day 1 on the first one, is using distributive property to factor polynomials. And then day 2, which will be a separate video on the next class day, you'll use zero product property. And it's a way of solving equations that will require us to put it back in this factored form. So big idea. What does it mean to factor something, or how do I factor? So factor being the verb, that's the action that you take. So in elementary and middle school, you worked on multiplication facts, and what they would tell you is that numbers that multiply together are factors. So in the example down below with 2 times 3 equals 6, you've got a factor that's 2, and you've got a factor that's 3, and the final result then is called the product, meaning the result of multiplication. So in the expression that's below that, it says expressions like x squared plus 4x plus 3 also have factors. So we used to be given the factors, and we had to multiply and combine like terms to get to the simplified expression. Well, now we'd like to be able to go in reverse. We'd like to be able to take the simplified expression, meaning its multiplication has happened and all of its like terms have been combined, and we would like to go the opposite direction and put it back into its factored form. So take a minute and add those two forms. Factored form means it's in the form where I can still see the multiplication of quantities, and simplified form means that parentheses have been taken care of with distribution and all like terms have been combined. So we were used to going this direction, and now we're going to try to go the opposite direction and get things back in that form. So in the box, we want to put the big picture ideas. Factors are values that are multiplied. So anytime you see factors, they are the items that are being multiplied to get a result. So that's one big term to know and definitely put on our note card. Throughout the video, I want you to pause it when you need to catch up on notes, or if you think there's a term or something you want to put on your note card, get one right away from the stack of extra note cards and get started on your Chapter 8 note card for the second unit. So as a verb, if your directions are to factor, or if we are factoring, then it's the act of finding those values that multiply to a certain quantity. So we're going to start with some basic ones, and we'll put them under the we do. If our expression is 15 and we would like to factor that, we would like to come up with things that multiply back together to be 15. So we could say that 15 is, and some factors that we could have, 3 times 5. So there are factors of 15 that are 3 and 5. We could also say that the factors of 15 are 1 and 15. And we're going to stick with factors as being positive numbers. Every once in a while we'll need to use some negative ones, but for the moment let's stick with some positive factors, meaning all the different things that multiply and make 15. So its factors include 1 and 3, 5, and 15. Different numbers that when we combine them by multiplication, we could get 15. X squared actually has quite a few factors. So x squared can be written as x squared times 1. So x squared and 1 are both factors of x squared. We could also write x squared, though, as x times x. So x squared has 3 factors, 1, x squared, and x. 3 things that can be involved in a multiplication problem and get to x squared. And then 8x has a lot of different factors. So let's think of the things that we know about. We could just multiply an 8 by an x. So 8 and x are factors of 8x. We could multiply a 1 by 8x. So 1 and 8x are factors of 8x, individual components that I can multiply by something else and achieve 8x. But there's actually more. What about 2 and 4x? So each of those are factors of 8x. Or 4 and 2x. So there are lots of factors of 8x, lots of values that could be listed and multiplied together to get 8x. So pause the video, list the factors of 12, just like we did up above for 15. See if you can come up with all the sets. List the factors for 6x squared. And again, try to list all the different combinations we can come up with that could make that. And then 20x cubed, and come back to the video only once you have those done and you're ready to check. If you're back, that's because you're ready to check. You should not just be writing this down. You need to pause the video and actually try this out. Factors of 12, you should have 1 and 12, 2 and 6, and 3 and 4. And they don't need to be in that order specifically in each factor expression, but those are different things that would multiply and make 12. For 6x squared, we could have 6x squared times 1. We could have 6x times x. We could have 6 times x squared. We could have 2 times 3x squared. There are lots and lots and lots of combinations. We can have 3 times 2x squared. We can have, I think I was missing one. Yep, I was missing some. We could have 2x times 3x. So we have many different factor combinations that can make 6x squared. So if you're missing a few, pause the video and get the rest in there. And 20x cubed, ooh, some factors could be 1 and 20x cubed. There are many here. We could have 2 and 10x cubed. This could be a very long list. We can have 4 and 5x cubed. Now, we can also have things like x cubed times 20. So just moving those around in slightly different combinations. And so let's think of not necessarily every one of them, but some of the other ones. So I could have a 2 and an x multiplied by a 10 and an x squared. I could have a 4x squared multiplied by a 5 and an x. So I'm just going to put the arrow down, meaning there are many more, and you might have come up with some of those. And the reason we practice that is that's going to build our skill for what we need. So when you go to the next page, it's going to give you a sentence. Factoring is often said to be reversing the distributive property. And many of you are really, really, really accomplished at distributive properties, so we want to go the opposite direction, and this will be a new skill. So we say to expand, sometimes we say to simplify. We use the distributive property to multiply things from outside the parentheses into the parentheses. So if we said to expand, and you may need to darken the arrows and the letters on your paper because this came up a little light on the photocopies, we'd be going that direction. We'd be distributing that 2 and making it 2y plus 6. If we started from 2y plus 6, though, and we went in the reverse direction, then our verb that we'd be talking about is to factor. And basically, we want to reverse or undo distributive property and come up with a number that can be divided into both 2y and 6, and therefore it's something we can pull out front and say that number could distribute back out into that expression. So we're looking for equivalent expressions. Math has an interest in getting things out of factored form to be simplified, or from simplified form back into factored form for some of the solving that we're going to need to do of equations that aren't all first powers on the x's. And that's coming. So the first example is to have us monomial factor the expression 3y squared plus 12y. So we want to look for all the factors of 3y squared, and we want to look for all the factors of 12y, because we want to find out what is the number or combination of numbers and variables that is its biggest factor that they each have. So greatest common factor means I want the biggest one. Common means it has to be for both terms. Has to be a factor of both terms. So for instance, 6 is a factor of 12, but it's not a factor of 3, so I can't use it. Ooh, don't know why that came up. Must have put my hand somewhere funny on my screen. So let's try to get rid of that. Nope, I don't want that at all. Go away. Okay, don't know why it's doing this, but we may just have to deal with it doing that for a little bit. Okay, so those monomial factors of this, sorry about that. So for 3y squared, my factors are, I know that 1 times 3y squared, so 1 and 3y squared are each factors. I know that 3 and y squared would be factors. I know that 3y and y would be factors. So I've got a list of different factors that could possibly be going in here. And for 12y, what I'm going to do instead of listing each set of factors is I'm going to list all the factors of 12, which are 1, 12, 2, 6, 3, and 4. And then there's definitely got to be a factor of y, and if I multiply different combinations of those, I could get 12y. So I want to look through my list and see what they have in common. In my bottom list, I have a y factor, and in my top list, I have a y factor. I don't have y to the second in both lists, so the only y factor that they each have is a single factor of y to the first. As far as the biggest number factor that they each have, I see 3 in the top and I see 3 in the bottom, but I don't see any factors bigger in that top expression. So here's what I know. I know that the greatest common factor, it says factor the greatest common factor from each term. I know that they each have a factor of 3, and I know that they each have a factor of y. So the largest factor that each term has is 3y. And I'm going to reverse distribute. I'm basically going to pull that out and say 3y times what needs to be sitting in here so that I get 3y squared out of that multiplication. So that would need to be a y. Plus 3y times what's going to need to be sitting here so that I get 3 times y gets me 12y. So 3 times 4. So my factored expression then is this one. I've put it back into that distributive property form. We're going to try this again. Again, pause the video when you need to catch up or think about things. So we have to look for, in this 3-term or trinomial, we have to look for the one thing that they all have in common. So I'm going to go down and make my list of factors. For 32, that list is going to be pretty long. Numbers-wise, 32 and 1, 16 and 2, 8 and 4. These are my factors number-wise. Then for x squared, x is a factor of x squared, and so is x squared itself a factor. So those are all the smaller parts that I could break that into and multiply different combinations to make 32x squared. For 24x, I know I could have 24 as a factor and 1, 12 and 2, 8 and 3, 6 and 4, and a single factor of x. All the different things that could be multiplied to make 24x. And for 8, thankfully, it's 1, 8, 2, 4. So pause for a moment, make sure you can make factor lists like that. And then I need the greatest common one. So when I go through, I see in the bottom row not a lot of numbers, and I see 8 being the biggest number in the bottom list, and I do see an 8 in all 3 of my lists. So as far as numbers go, the greatest common factor number-wise, they all have is an 8. And my bottom one, the 8 itself, doesn't have any variables in there. So since it doesn't have any variables, I can't use any variables in my common factor because one expression doesn't have any. So my greatest common factor for all 3 from all 3 lists is an 8. So 8 is that distributor, and I have to figure out how it made my different terms and tell it what would need to be in the parentheses. So if this was caused by 8 times something, we have to say it was 8 times 4, and there must have been an x squared plus. 8 times what to give me 24x? Well, 8 times 3 gives me 24, and now I need an x. And then I do need a third thing here, and people say, well, 8 already is 8. Right, so 8 got distributed or multiplied by a 1 to make that. So my final factored form is right here. Now I do these pretty quickly, so I want you guys to stop the video and try to monomial factor, meaning find that greatest common factor, pull it out front, and write the parentheses that you would get, and then come back to this video to see if you got it right. So you're pausing the video and coming back. Pause it now. Seriously, pause it. If you're back, it's because you went through and made a list of the different factors of each of these. And the largest common factor, the GCF, should be a 3. And that's it, because they don't all have an X factor. They don't all have a Y factor. And some of them aren't even, so they're not divisible by 6. So if my greatest common factor is 3, my factoring answer, or my factored form, should be to take that 3 out front, and then think 3 times 2, and then an xy to get that 6xy term, plus 3 times 6 to make 18 with an x, and then a minus sign and a 7. Again, get a calculator out to see what multiplies together to be what. Factoring has a couple different flavors or kinds. So you just were working on monomial factoring. Monomial meaning find the one term that they have in common and pull that out of everybody as one distributor. So they've got an example of 18x plus 24. Pause the video, see if you can factor it, coming up with the GCF here. And then what would be left to distribute over to get 18x plus 24. If you're back, it's because you recognize that the GCF here should be a 6. List the factors of 18, list the factors of 24, and take the biggest possible one. And 6 would have to get multiplied by a 3x to make 18x, and by a 4 to make 24. So this is our factored form. This is more work than we were doing in the last chapter when we were multiplying and simplifying. This is going in reverse. Then there's also something called binomial factoring. This is going to be where we start today a little bit, but we really work on this in future days. And this means that there were 2 distributors multiplied by 2 things, a binomial times a binomial, and we want to try to get it back into that form. If you notice the GCF for these 3, they don't appear to have any common factors, but our GCF is always 1. If they have no other common factors, 1 is a factor of everything. It's kind of a useless factor because it really doesn't help us. We're not going to pull a 1 out of everything. Eventually, and you're not going to know how to do this quite yet, eventually we'd want to get this back into a form where if we multiplied it out, we would get x squared plus 5x plus 6. And if you check what I just wrote in there, that will work. So this is our next factoring type that we need to try to find ways to do. So GCF, or monomial factoring, came first. And now this is our next factoring type, is binomial. We always try to monomial factor first, so I'm going to leave a little note. Always monomial factor first. And then eventually we're going to work on that, then afterwards getting the binomial factors. So, oops, sorry, again, trying to get rid of this, and it's not going very well, is it? Let's see if I can't get rid of that. Can't. Oh, down. Okay. So, want to work then on monomial or binomial factoring. And again, sorry about that. I don't know why that keeps coming up, and I don't know how to make it go away. Actually, let me try that. That worked. Okay, on your next page, your final page, we're going to talk about how to binomial factor. Okay, and then we'll actually get your homework going. And this video is a little bit long, so if you needed to pause and take breaks, that's what you should do. So binomial factoring, one way is grouping. So we're going to take a set of 4 terms, and this is a 4-term polynomial here, and we're going to group them with common factors. So I'm going to take the first 2 only and make a group. And in that first group, I recognize that their greatest common multiple, or their GCF, for just that first group, is a 2 and a y. So I'm going to factor that out of that group, and that should leave me with an x minus a 1. I'm going to take a different color, and for the second group, including the plus sign here, I'm going to say that in this group, my greatest common factor is a 7, or a positive 7, so I need a sign in between there. And for that group then, x minus 1 would be my factoring. This is where you may need to slow down and try this out yourself slowly and coming back to the video when you pause. This isn't factored all the way yet. I factored each group of 2 items, but now it says I have to see what each group has in common. So my blue group and my purple group, and I see right away that they both have a parenthesis full of x minus 1. So x minus 1 is clearly something that has to get distributed over to make that initial 4-term polynomial. But there's two distributors. So we said if there's ever two distributors, what you need to do is combine them in the front parentheses. So a 2y has to distribute over x minus 1, and so does a 7. Now this is in factored form because I have a binomial times a binomial. So we're going to try this again. The next one down, we're going to take it in groups. I'm going to take the first group of two terms and find their greatest common factor. Since they're both even, I know 2 is a factor, and I see that they each have a y factor. So 2y is my common factor in those two. And then I'd need a 4 and an x to get the first one, and a plus 3 to get the 6y to come out. The second group, in the second group, it's really important that I take this sign, this minus here. And it looks to me like they both have a minus in common and a factor of 10 in common. So I'm going to take the negative 10 and see what happens. Negative 10 would have to get multiplied by a 4x to make that negative 40x. And negative 10 would have to get multiplied by a positive 3 to get that negative 30. Here's what you might start to notice about my two groups. My two groups have a parentheses that's the same in both. That's the only reason I can do this. Since my first blue group and my second purple group have a common group, I'm going to take that common group and recognize that that common group has two distributors that have to happen to it. They have a distributor of 2y, and they have a distributor of negative 10. So my final factoring on this looks like that. Last one. So when we have 4 terms and we want to factor binomial factoring, we're going to see if we can take it in groups. So let's factor this group. I see they have a negative in common. 2 and 10, their greatest common factor is 2, and they have an x in common. So my first expression will be a y plus, and then negative 2x times 5 to get my negative 10x. My second terms have a plus sign in between, so I notice that they're both positive and have a factor of 3 in common, so I'm going to take that out. That'll be a y plus 5 there as well. So this is showing promise because I'm seeing a common thing in both groups. Both groups show that a distributor happened, or two distributors happened to y plus 5, and those two distributors were negative 2x plus 3. Your task. And Alexis is here, the teacher aide, and the teacher aide Raquel in third hour, and you can ask questions, and tomorrow you'll keep working on this. So these are your tasks. So if you have class time left, please go get loose leaf, get this labeled, and then get started to work on it. This is 1 through 6 all, and then the odds are only the 15 through 25. So it's 1 to 6 all, 15 to 25